Okay, we're going to look at the multiple choice from 2023. We're looking at paper 1, tech 3. We're just going to look at questions 1 to 5 in this video. So opening my booklet up. The position of a particle is given by r is t plus 2i, t squared j. Determine the Cartesian coordinate. So I'd say this is my x, this is my y. So x equals t plus 2. So t equals x plus 2. And y equals t squared. Substitute that across because we're eliminating the t. X take 2 squared, which if you expanded x squared, take 4x plus 4. C is the correct answer. Question 2 is mathematical induction, considering the proof of the following proposition using mathematical induction. And it's using the sigma notation for summation. An approximate assumptive statement within the proof is. Now remember, our assumptive statement is when we assume it's true for n equals k. So we're basically substituting a k in wherever there is an n. In the first one, they've substituted k in when r is, so that's not going to be true. Same for b. Down here, so we're from C and D, and they've put, for the left-hand side, r equals 1 to k instead of r equals 1 to n, which is right. Then looking here, they've left the n's in. So C is my correct one because I've substituted the k's for the n's. Question 3. One solution of this cubic equation is z equals -2. Which equation could be determined the remaining solution? Now, if z equals -2, that means z plus 2 is a factor. Okay, because it'll be z take -2. -2, make my 2's better. So I just got to do a quick division. Z cubed minus z squared minus 7z minus 2, z plus 2. Z goes into z cubed, z squared times. Give me z squared times z is z cubed, z squared times 2 is 2z squared. Taking these away, negative z squared take 2z squared is -3z squared minus 7z. Z into this, so you take 3z. So already I can see it's going to be A or B is going to be my answer. So -3z times z is -3z squared. -3 times 2 is take 6z. -7 take -6 becomes -z minus 2. So z goes into -z minus 1. So A is our answer there, because -1 times z gives me -z, -1 times 2 gives me -2. Take them away, I get 0. I didn't need to finish that off. Once I got my -1, I could go, okay, A is going to be my answer. Question 4 is a Leslie matrices question. We're given a lot of information with the different age-specific population, the female population, the breeding rate and survival rate, the Leslie matrix based on this data. Remember, a Leslie matrix has the breeding or birth rates across the top and the survival on the diagonal. So here they've used the population across the top, so it's not going to be A. B is just random. They've used the ages in years. C, across the top, they have used the survival rate, so it's not going to be C. So look at D. Oops, sorry, D, they've got the breeding rates across the top and the survival rates on the diagonal. So D is our answer there. That's kind of a nice, easy one for you. Question 5. Confidence interval for a parameter is a range of values within which the sample estimate of the parameter always lies. So if we're looking at confidence interval for a parameter in a range of values within which the sample estimate of the parameter always lies.